All right, we're up and working. All right, so let's go to, this is unbelievable. Yeah, it's just amazing to me what computers can handle now. I mean, just 20 years ago or 25 years ago when I first bought my first Mac, or not Mac, Packard Bell 386 in the Okinawa exchange, Marine Corps exchange can't remember what the name of the camp was. Wasn't Camp Hansen. I think it was on Kadena Air Base. It was $1,000. It's quite a bit of money for 1992. But at the time, in the late 80s, IBM introduced the home PC, and it was like $4,000. And you had to buy boxes and boxes and boxes of these 5-inch drives and everything. And with the Hewlett Packard, it had 256 megabytes of ready access memory. And I mean, you could do anything. I mean, just what I'm doing here would have taken, just to upload these slides, would have taken 5 minutes. All right, sorry, I got off track. All right, so now, the near point of an eye, here's the near point of a far-sighted eye. It's far away. In other words, when I get older, as I got older, I had to hold my arms out farther away, and that was uncomfortable. I wanted to have the book at about 25 centimeters. That's where we hold it. Now, here's the thing. With small children, their near point is around 10 centimeters. So they like to have things up close to their face. That's why, if you ever watched like a 3-year-old or something like that, as I'm watching my grandchildren color, they are on top of it. I mean, they don't sit back and color. Their eyeballs are 10 centimeters away from that page while they're coloring. That's because that's where their near point is. And as these muscles loosen up a little bit, then their near point's going to get further and further away. Normal for those of you between 20 and 40, or 18 and 35 about, it's at 25 centimeters. And that's where we like to hold our books, about 25 centimeters from our face. And then as we get older, it gets to be 60 centimeters. When you're over 60, like me, it's almost a meter away. So I either need to get glasses or arm extensions, one or the other. All right. So let's look at a couple of the problems in the book. All right, from our homework. And I'm going to try one without working it out first, which is always dangerous. Always dangerous. And so here we go. Wait, I want you to just watch me make cheese here. Oh, that's still thinking. No. All right, hold on. Let's go here. That was the last one I just updated. Let's go to YouTube video, upload video. See, it's running a little slow because this is my Mac. The other night when you were watching me do this, oh, that's still loading. No, it's ready to go. I put 2 and it should have been 1. All right, so that's up and going. All right, so I've gone to assume a lens to retina distance of the human eye is 2 centimeters. All right, so let's look at a few of these eyeball problems and things like that I have here. Okay, so this is chapter 25, 26, 27. I mean, it's a conundrum, but it's basically the eye. All right, the distance of an object is 6.5 meters. Calculate the power of the eye when viewing an object 6.5 meters away. Okay, let's convert everything to meters. Okay, let's convert. Now this is the image distance, and it's a real image, so therefore it's 2.0. I mean, it's positive. Okay, this is the distance of the object. Let's figure out the power of the eye at when it's doing its thing. It should be 50 plus. I'm hoping it's 50 plus. Let's take a peek. This will be fun because I haven't done this yet. And I already forgot what the darn problem was. So here's what we're doing. We've got distance of the image is equal to 0.02 meters. Distance of the object is equal to 6.5 meters. And so we're trying to find the power in the eye. All right, so this doesn't have any kind of no tricks, no fuss, no muss. Here it is. So we'll say, all right, well, the power then, because it's 1 over f in diopters, because remember, it's 1 over f in meters in diopters. 1 over f in meters, okay, is equal to 1 over 6.5 plus 1 over 0.02. Here's my 50. So this will equal plus 50. .158. Let's go with 1.154. So the power I'm going to say is 50.154 diopters. That seems like a funny number, but we'll see. That's got to be right. Oh, whoo! That was fun. Let's try one more. Okay, suppose the person's eyes have a relaxed power of 50.99 diopters. Okay, cool. Assume, again, distance of the image. All right, and there's my power. What is the far point of the person in meters? We just did something like that. We just now solved that. Okay. Again, they're not being assisted by glasses or anything, so we've already done that for the most part. Let's look at 4. Consider a person whose eye has fully accommodated power of 56.5. Assume the distance from the lens of the retina. Okay. What is the near point? Okay, consider a person whose eyes have fully accommodated power. All right, so 56.5. So they can really squint and see up close. All right, so what is the near point of this person? Well, this might be interesting. This might be interesting. So here we go. So the power. So this is what, problem 4? And I'll probably do 1 or 2 more on this, and then not on this go round, but on coming up. And then we'll catch any catch-all problems because we got to move on. Okay, so the power is 56.5, which is diopters, which is equal to 1 over. So here we go. So 1 over 0.02, which is our distance of our image, plus 1 over what the see I'm getting so old I forget already. Oh, we're trying to find DO. All right. So what am I doing? Driving you crazy. So I've got 56.5 plus 56.5. Now we'll know this is 50, so minus 50 is equal to 1 over DO, which is equal to 6.5 meters, or 6.5 diopters, which is a distance in meters. Okay, so DO then distance of the object is equal to 1 over 6.5. Okay, and this would be in meters because the diopters is in per meter, so that we flipped it up and we got the meters. So 1 divided by 6.5 is 0.153. This is a lot like 8 meters. So it's about 15.38. So their near point in centimeters is 15.3. They've got to have it really close. They got to look really, really close. They can't see. This person is myopic, so they need glasses so they can move it further back. All right. think that's probably right. I don't know why it'd be wrong. Distance of the object in centimeters would be 15.38. Wow. Dang, I had to blow this. All right. We're looking at slits. What else we got here? What's on 11? Yay, we're almost done with this entire thing. Now we go on to chapter 27. Okay, so we've looked at the eyeball. We know we've looked at lenses. This has been good. You guys have been great. All right. Let me see how far this is going. This process